we need to understand the implementation of the decision tree for the regression. So as we know, the regression means we need to use the predict, we need to predict some data, predict some information by following the decision tree approach. So let me explain each and every step properly, and whenever you have any doubt, then you can ask me. So what is the problem that is to be discussed over here, and we need to discuss the predict the salary of an employee based on years of experiences. And if you remember the linear regression problem, and that part we have already discussed to predict the salary of an employee. Are you remembering the data set which is to be discussed into that our practical session, the linear regression we have discussed? Are you remembering the point, salary data?
Yes, sir.
Okay, so same data set we will use. We are not changing anything. And so what we have today, we have the difference between the linear regression and decision tree. And from the practical, we will decide which model is better. So simultaneously, we will implement two models, one is linear and one is a decision tree. So what is the step number one? Step number is saying to us to load the data. So before you speak anything, just let me know the screen is visible perfectly. The content which is written over here is visible to all. Just let me know.
Yes, sir.
Yes, sir.
Visible, sir.
Okay, good. So what is the step number one? Step number one is saying to us to load the data, and we can use or we can get data by the dictionary, list, or tuple, or array, or any other medium. So here we have using the very defined data set, and we have already created the data that is known as the salary data. So if I'm executing this code with the help of the pandas library, I'm used to pandas library to data represent data in the data frame. And as we know, data set equal to p.ucs. So with this method, we are reading the data file that is the salary underscore data.csv. And with this point, what we are doing, we are just we are printing printing number of columns. Or here we can say these are known as the features. Okay, these are also known as the features. And after getting this point, we can say so how many columns we are having over here. We have the year of the experience and salary. So as we know, we are talking about right now the dysentery with regression. So here we need to decide which is the independent variable and which is dependent variable. So as we know, the year of the experience column will be the independent variable and salary will be the dependent. Why? Because based on the year experiences, we can decide the salary of an employee. Okay. So same statement we are using as we have done to the linear regression. So x equal to dataset dot ILC. So ILC means index location. So from the total number of the column, we are choosing zero location index. That is zero location index is identified by the year of experience, and salary belong to the one index. From this point, we need to get the values of the respectively columns. That is the year of experience and salary. After executing this code, you will able to see the data set which consists the entire detail is showing over here. So now it is visible to all. And now let me know it is visible to all. The year of experience, salary, entire data description from year first 1 year to 20 years. Is it visible to all? Just let me know. Any doubt here? Please ask me. Any doubt you are having? Please ask me right now.
No doubt, sir.
Okay, good. So what is the next step? After under reading the data, what is the next step? As we know, what we need to do? We need to get the data from we need to get the training data and testing data from the entire data. So next step is saying to us, you can note down step number two. What we are getting the training data and testing data. We are getting the training and testing data. So how we are getting? Suppose by just using the train underscore test underscore speed method from the model selections class, we are using that part. So the x train is the name of the variable, the x test, by train, and by test. See, these are the four different kind of the variables, and you can use A, B, C, D, whatever you want to use. These are not a fixed variable. These are the only the simple variable just like the use different variable. So you can define all these variables as according to demand. So don't worry. If you want to change it, you can change it. Now, total number of the values. How many total number of the values we have? Please tell me how many values of the data. Total number of the data we have the 20. From this 20 data, just tell me what would be the size of my testing data. Just tell me. So according to your demand, we can update. Just please tell me. Here we have written into the 30% as according to the previous slide. But if you want to change it, then I can change it. Now tell me what would be the size of the testing data.
So
60, 66. I
so
am
six.
speaking of 6%.
Yes.
6%.
Okay, 6% would be your test site data. So 20, so
Six number of element will be there in 30% of test size.
yes, definitely. But I'm asking the how much percent you are looking for the testing data. So can you tell me the test size data you want to change, then I can change. It is already written previously, but if you want to change, it's 25%, 40%, or whatever you want to say, you will tell me.
20%, sir.
So, okay, according to the one student, I'm changing it. He is saying, sir, 20%. So from the 20 data, if I'm choosing testing data for the 20%, so there would be the 4 records or 4 values. Okay. And ratio 16 value will be followed by the following by the training data. Okay. Let me execute this code and see what would be happen. Okay. Now internally execution is going on and my data will filter into two important part by the randomly manner. That is the test size is the 20%. So 4 information will go into the testing and remaining 16% will go into the training. And with help of the training data, I will train my model. Now it is executed perfectly without any error. And after this point, if I try to print some information, now see what the value it is printing. It is printing the 16 values. Let us check the testing data. Yes, the 4 values randomly coming from the 16, 6, and what we have? We have the 10 and 19. So finally, we are getting the 4 values from the 20 values. So we can say now our model is ready to train. But before that, we have calculated the training and testing data. So we got the entire data. Same thing we will look for the y-axis values. Next, we are going for the y-axis. So respectively, the year experiences we have the 16 years. So value will be the 1 lakh rupees. And with the person who has experienced 10 years, then person will get 50,000 salary as according to the data. Now, after this printing the information, just let me know here. Do you have any doubt before starting any step? So we have completed 2 steps: load the data and load the data and now tell me what is the next step? And we have done the splitting of the training data or testing data. Okay. So now tell me what is the next step? Our next step is saying that now it's our responsibility to build our model. Okay. So should I explain third step number 3 or do you have any doubt? Then you can ask me. Just tell me any doubt.
No, sir.
Good. So as according to the linear regression, we need to build the model first. So we need to implement the 2 models. One is the linear regression and eccentric. First, I will tell you about the linear regression. As we know, all the steps as we have seen into the linear regression, we will do the same out and out. So we are building the model. It means we are fit the linear regression to the training data. So before that, what is our objective here? Our objective here is saying to us what we are doing. We are building we are building the model for linear regression. So first we are building the model for linear regression. Okay, using training data. Using training data. So now how we can do? we need to call linear regression method from the linear model library or linear model class from the sklearn library, as we have done into the previous class. That is a regression we have used. So I'm just changing its variable name for interesting purpose. That is regression underscore lin. It means it defines the linear regression variable. Okay. So same pattern we are using. So the object what we are creating here we are creating the object of linear, linear regression. After creating this one, we need to fit our model, and that we are fitting our model based on the training data. So that is required to do. And after fitting our model, so we can say our model is ready to build here. And after clicking on this point, so we are getting this point, we got a message linear regression. It means my model, what we have decided, that is to be built here without any doubt. So same process we have done in the previous while creating the linear regression model. We have done same process we are applying over here. Tell me any doubt in this point? Tell me any doubt in this point you are having. Please you can ask me.
No, sir. No, sir.
So step number 1, 2, 3, there is no issue. What
No,
is the first step? Load the data. Second step is saying to us, you need to filter your training data, testing data based on the randomness. And now we are building the model linear regression. Now is it clear?
yes, sir. Clear.
Okay, good. So what is the next step is saying to us, we are doing something over here. Okay. So next step is saying to us simultaneously with the help of the using the training data, we will build the next model, that is a descent tree for regression. So here what you need to do, we are also building the model by descent tree for the regression. So here keep in mind, here please listen carefully, and I'm just focusing on those points. Previously, we have used the linear regression from the linear model class on sklearn library. If you want to build the descent-tree regression approach, you want to use a descent-tree regression approach, then use a descent-tree regression method from the tree class pulling by the sklearn library. That is one you need to keep in mind. Like a regression lead where objects, you can create your object name, that is regression underscore dt. If you want to use xyz, then you can use a username. These are the not fixed or standard variable. Okay, these are the user defined, so we can modify as according demand. And descent tree regressor is the name of the method which defines the descent tree with a regression. So if you're saying, if you are choosing, if you're creating the descent tree with the regression, so what we are doing, we are expecting something. So what we are expecting something, we are expecting the salary of employee. So we need to check if we are calculating the, or we are expecting, or we are predicting the salary of an employee by the linear regression, then what result we will get. And if we are choosing the same thing by the descent tree, so what result we will get. And that is the biggest difference we need to take care here with the help of the practical. Now, after doing this activity, and that is by calling the descent regressor method into our this part, then after creating this object, that is a descent regressor underscore dt. Here we need to pass some parameter. Random state is just optional part. Okay, if you are not using, by default the random state is equal to 0. So we are writing, we are not writing, it doesn't mean it's option part. Just like the descendant regressor, we have the different kind of the other parameter. So there we are not touching other kind of the parameter, and that is not part of the here of our problems. So we are not bothering about the other parameter. See, in any method, in the any library of any kind of the program, any kind of the products, we have the huge number of the parameters of the any method. Maybe. So depend on the problem we can use. So we are not bothering about its parameters, so we are not using. But if you need to pass the some parameter, that is not required. So we can leave it. So here I am giving the other parameters over here. So right now I am using only the random based. It's option. If I am not using, it's the option part. For understanding purpose, I am using right now only. So we can use any random state value. So in the decision tree will choose a value from the randomness, and from that point, a decision tree will divide the data into the two different parts, left and right node, to distinguish your information. So how the random state parameter will work, I will tell you later on while showing the decision tree. But this is the point you need to keep in mind. As according to fit the linear model, we need to fit this model by using its object, that is the regressor, regressor underscore dt. And of course, we need to fit the our this model by the same training data. So here we are using same training data variable. Those are the X train and Y train. The syntax you have to keep in mind is a syntax. Decentrally regressor is a method which is inside the tree class. That is the one you have to keep in mind. Please remember this one. So after executing this point, you can see what we have seen. We have built our model. So a message will be displayed over decentrally regressor random state equal to 0. It's optional, but we have used. If you are not choosing, so by default, your random state value will be 0. Now tell me, at this moment, do you have any doubt? Tell me, any at this moment? Just tell me any student who have any doubt right now. No doubt, shall I move to next part?
Yes, sir.
Okay,
Yes, sir.
okay, good. So in the next step is saying to us, you need to build the model. So after building the model, what we have seen, we have done the three different activities. What are those activities? Just I'm explaining via my approach, then you will understand in better way. See, right now I'm sharing one more thing, and you will be able to you will be able to understand this one. Now, the shared screen is visible to all. No, MS Paint.
Yes, sir.
Okay, so see what we have selected. We have the huge amount of the data set. From this data set, you have first you have load the data, and from this point you have done this activity, that is the training data, and you have chosen the testing data. Okay. Now, next step is saying to us, we need to build our model. So, what is the next step? We are building our model here. So, we have the two models. One is the one model, another second model. This model is use the linear regression approach, linear regression, and this model is use the approach that is known as the descent. This is known as the linear regression. So by using the training data, what you will do, you will build the model by using this data. So this step is saying to us, building the you are building the model. You're building the model. Now, is it clear? Tell me, is it clear right now? The diagram is clear? Tell me, diagram is clear? Okay, tell me with the diagram concept is clear?
Yes,
Yes,
sir.
sir.
Okay, so with help of the testing data, you need to predict. So what will the step is? We have the step that is known as the prediction. What is the step? We have the prediction. So prediction is basically a step. So the prediction can be done by the two way, using new data or from the existing data. Okay, that is what. From the new data or from the existing data, we can do the prediction. So we have the existing data, and we can put the new data. If you are saying you want to predict your model first before putting new, so you can use the existing data that is identified by the test data. Okay, like this. Or you can do just you can test data from here. Okay, so prediction can be done by the test data. Prediction will be done over the prediction will be done over the prediction will be done over the on the linear data as well as decision tree model. So prediction will be done by the linear regression model and decision tree model. Now this step is clear. This step is clear. So what is the first step? First step, we have the huge amount of the data. The huge amount of data. We filter our data into different way. Okay, so this is our first step. Second step, we are creating our model. So that is second step. Third step is saying to you are building the model. Okay, so I'm putting the three. Fourth step is saying to that you are just predicting something. So I can mark in the circle for understanding purpose. So fourth step is we need to predict. Third step is to build the model. Second step was training the data, and first step was the load the data. So these are the four steps we have completed. Now, clear? After getting the prediction, we will have some information. We will have some information. Okay. So after predicting, so what we will have? We have the some outcome. We have the some outcomes by linear regression and decision tree. And if you are putting new value, so you will also have some, you will also have, you will also have some outcomes by both model. Those are the LR and DT. But here we have a question. What is the question? The question is still we have in our mind performance. Okay, that is the point you need to keep in mind performance. Okay. The performance of these model can be measured by performance can be measured by these model measured by our parameter that is known as accuracy. Okay, so here we need to predict the new value or new salary of a employee who has some experiences based on the model prediction. But if we are choosing both models, so which model have the good accuracy that is to be calculated by us. Now tell me, this diagram is clear? This diagram is clear? Any doubt over here? Please tell me. This diagram is clear? Yes, tell me. Any doubt over here? Any step you are not able to understand? Please let it know right now. And any question you are having, please you can ask me right now. The complete flow of the program is clear.
Yes, sir.
Okay, great. So I'm again back to my program, which describes the entire details. Now, let me know once again the screen is visible of the Jupyter notebook. Yes, it is visible.
Yes, sir, it is.
Okay, good. So next step we need to do, that is the predict the model by testing data. Okay. So what is the next step we have? We have the next step to predict the model by testing data. So from the testing data, we need to predict our model. That is the we have variable by prediction length. So I'm taking a variable name, that is the by prediction length, that is a U-defined variable. For understanding purpose only. So we are predicting something by the linear regression variable. So we use the regression underscore length, that is the name of the variable, and to predict something from the X data. So by the testing data, we are predicting. Same thing, we will go for the by prediction dt. Dt means descent rate. So this is the name of the variable, and with this approach, we are predicting the testing data. So after this point, just let me execute this code, and after executing this code, we found that there will be some values. So what is the value we are getting? Okay. So here in the next step, you have the solution of the printing way. Then you can see after executing this point, the testing data we have about the four values. Those are the 16, 9, 10, and 19. So we have this testing data. So on this testing data, if we are predicting the testing value by the linear regression, so we are getting the person who have the experience 16 years will get the salary 1,615. So we are getting the close value or maybe the more or less value in the linear regression. But in the descent tree, we are getting the exact value, and that is meeting with the our, or that is our matching with our data set. Please observe over here. The person who have the experience 10 years, according to linear regression, will get the salary 68,866. But according to recent tree, the person will get the salary 60,000. So please keep in mind, the person who have the experience 10 years will get the salary 68,086 866 by the linear regression, and by the recent tree will get the 60,000. So move back to the our actual data set. The person who have the experience 10 years, if according to data set, the person should get the salary 50,000 according to our defined data. So if the model is, we are building the model by the training data, we found result that the person who have the experience 10 years, then according to linear regression model, I need to pay 68,866. Now there is a huge difference between the 50,000 rupees and 68,000. So 18,000 rupees I need to pay extra according to linear regression model. But when talking about the descent tree model, so descent tree model is just observing over here, observing over here 60,000 value is close to the two values. One is 50,000 and 75,000. But 50,000 to 60,000, there is only the 10,000 gap. But 60,000 to 75,000, we have the 15,000 gap. So the minimum gap or the minimum difference we are having by the descent tree. So descent tree will choose only the exit value which are part of our salary data value. So the descent tree will give only those results which are from our data set and meeting the exit value. It will not add something, it will not remove something. So value of the or the prediction value will not be updated at any cost in the linear regression. But in the descent tree, but in the case of the linear regression, it will be updated. So why it is updated? Can anyone tell me why it is value is updating? We are not getting the exact value, we are not getting the close value as we are getting from the descent tree. Can anyone tell me why we are having the little bit difference? Why we are having the difference? We are not getting the correct value and not getting the nearby value, which are meeting to our salary values. Just tell me. Yes, please tell me. Speak fast. Just tell me.
Yes, sir. Sir, can you repeat the question?
Why you have not listened the question? Why you are not
Sir,
here?
for linear regression, why the difference is more?
Yes, definitely. See, okay, more is okay, but we are not getting the here predictive value which are meet which should be meet to our salary data value. That is 60,000, 50,000, but we are adding something like the 68,800, and this value is not a part of the salary data values. But in recent tree, we are getting the value just like the 90,000, 45,000. All these values are meeting with our data set. But they all from these values are not meeting any kind of data sets. So now tell me why? Can anyone
Because
tell
in
me?
the data set there is not equal interval. In the data set, the salary doesn't have equal intervals. So linear regression will try to make it in equal intervals and then predict what is.
See, that's the point you are missing over here. I'm expecting answer from your side, all the sides, please. In the linear regression, we use a linearity following by the y equal to mx plus c. So the data plot which are actually plotted on the our information, that has some different value. But the line which is going to close to the point or maybe little bit far from the point. So the actual point of predictive value there is some gap, and that gap is known as the error. So due to this error, the value we are getting in from the not in from the exact way. We are getting the value in from the predictive way, or maybe we are adding something. Actually, what we are adding something over here. The value which is added by the some error. Actually, what did it contain? It contains some errors. So we are not getting the exact value 60,000. We are having the 60,000 plus some errors. 68,000 means we are adding something that is an error. That is the point. This is a drawback of the linear regression. But in the descent tree, we are not adding any other things. So we are having the exact value that is 60,000, which is close to the our data points. Now see here, if I'm giving the salary of the 10 year experience person, so 50,000. According to me, I should give the 50,000 rupees. But my model is suggesting 68,000, 60,000. So now tell me 50,000 close to which one? 60,000, 60,000. So definitely I will choose a 60,000. So tell me which model is better right now. 60,000 value I'm getting, that is my point. So from this point, I have tested my data. So there will be no issue. I'm rerun once again, so there will be no issue. But from this point, it is not a justifiable point. Suppose I am putting any new value. This is the tested data by the existing information. But if I'm putting a new value, suppose like the person who have the experience 3 years, 3.5. Okay, like this one, 3.5. Same values I am taking, but instead of the X test, I just need to pass only the new value that is 3.5. So right now I'm predicting my model by using the new inputted value. Okay, so predicting a new value and that could be any year. So can you can see over here the new value that is a 3.5. The person who have the experience 3.5. So you can say the person who have the experience 3 years who have the salary who will pay the salary 30,000, and the person who have the experience here 4 year 35 will give 35,000 the person will get. So if I'm executing this code, then you can observe over here predicted salary by linear regression we are getting the 28,471. So what you are doing from this point, the person who have the experience 3 year, but person should get the salary 32,000. But the person who have the experience more than the 3 years, and what this model is doing, model is decreasing salary, and that is not a good model. But according to decision tree, if you are using this approach, the decision tree is decided to that the person who have the experience 3.5 year experiences, the person can get the salary 32,000 or 35,000. So 3.5 value is the 3.5 value is close to the 3. So the model will decide automatically which value should opt 3 or 4. So that is the beauty of the decision tree. So it choosing the value 3 and it providing the 32,000. So this model is not giving the wrong information. It is providing the correct information or the accurate value by which we can say the person who have the experience is 3.5. So it's okay. But I'm changing little bit in front of you. Then you can see the person who have the experience 3 years, 7 months. So I can do something over here. I like this one. And do the some changes. So now automatically you can observe here the person who have the experience 3 years, 7 months, the salary, the person very close to the 4 year experiences. So definitely the my model updated the salary of the person 32 to 35. But according to linear model, linear regression model, what you observe here, you can see the person though very close to the 4 year experience, he should get minimum 30 to 35,000, 30 to 35,000. It should be a range. But he is getting only 29,000. So what is the this is happening over here? This is not a good model. Now tell me at this step, do you have any doubt? Any student who is just having any kind of doubt, please you can ask me right now. Any student, anything you are not unable to understand
Sir,
right now, please
I
tell
have a
me.
doubt.
Yes, tell me.
Sir, in this code, if we use polynomial regression instead of linear regression,
Yeah,
then what will
yes. See, that time you need to do nothing. What you need to do, you need to do something over here. You need to build a new model by using the here. You can add something over here. What you need to do, you need to call the linear regression. You need to add some polynomial feature, and the code we have already the polynomial feature or polynomial regression. That code we have to use over here, and we need to fit the model as according to the polynomial feature base. So definitely we will have some information. Don't worry. So that is your that is your activity. So you can try with the polynomial regression. What is the we are getting? It's up to you. No problem. Yeah, just I am taking only simple example to distinguish between the two different model only. That is linear regression and we have the decision tree. But if you want to use, so what you need to do? You need to do something over here. What you need to update this code by the linear regression. Then you can update. No issue. Just what you need to do? You need to do linear regression and you need to add some polynomial feature over here, and then you can fit the model. There will be no issue. Okay, you can do, or should I do right now? Okay, now tell me. Just tell me about
Sir,
the
please do
code.
it.
Okay, so I'm just opening the polynomial regression code. So rather than the typing, it is better idea to are copying only those parts from here. So you can see able to see. I'm not doing something new. So we have the linear regression. We'll fit the model. Okay, the model will fit. Yes, polynomial feature degree and exporting. Okay, I'm just taking this code as it is and just add over here. Okay, so in the strip model, so here I can write we are also uh, building the uh, model by polynomial. Okay, polynomial regressions, and I'm just copying all the thing over here. So I'm using the polynomial features over here, fitting the model with two poly regressions. There will be no issue. The variable will go fine. So here we have the variable poly regression. Please keep in mind this important variable right now. So here we have the variable polynomial regressions. No issue. It's okay. And after this, what we need to do? We have printed all the value, and we need to predict the our thing. But so just give me 1 second. Let me execute this code. Yeah. Yes. No issue. And let me execute this code once again. And let me execute this code. And here, yes. I need to take another variable, and that is here. So that is why by predict by poly. Okay, so poly is equal to what is the name of the variable? That is we have poly regressive. Okay, so keep in mind this point. So poly poly predict, and that we have the predict and x underscore test. So what we are doing here, we are the predicting the model by polynomial regression, and we are printing this value over here. So just let me add some line over here, this one and this one. Here I'm just adding polynomial, and what I need to use, the by print poly over here, and just let me execute this code once again, and this code again. Where we are getting the mistakes, polynomial feature object no predictor. Linear regression, just show it's fully updated. So for the linear regression, we need to use poly. Okay, we need to use this syntax, that is a predictor. We need to fit transform method we need to use. This entry, yes. So in poly regression, we need to use this method right now, and we need to write this one instead of here. We can pass x underscore text. Let me check once again. Now this is a fit into once again, and now we are printing this one. Now here we are having the some values. Now it is visible right now. It is visible all the data by the polynomial as well.
Yes, sir.
Okay, so you can see over here. Finally, what we got after building the model by the two different model as well, linear, polynomial, and dysentery. So we are comparing right now. So linear regression just giving the value 68,000 something. So the same, we are getting the 56,000. Here we are getting 60,000. Okay. So now let me execute this code once again by the updated part. So I'm just using the variable name. What is name of the variable? By predict poly. Okay. So here I'm picking the y predict poly, and that is we have the variable poly dot poly underscore, but here we have to use the predict method that is to be done by the fit transform. So instead of the okay, sorry, this one should be poly. This not should be false. Sorry. So we need to use this one. We need to pass the value. Yes. And instead of doing so, what I need to pass? I need to pass this value. So I'm just copying same value over here and see what we are getting. Fit transform, we put to this values and let us check. This is executing. Yes, now this is executing. So now I'm just printing another part over here. It's already via the polynomial integration. Okay. So polynomial integration, and here the value would be the poly. Let me execute this code once again. Now we are getting the value 34,096. That is lies between the 30 to the 35. But we are expecting the person should have the year 4 years. So we are providing the 35,000. So we have this value. Now all these values are visible to all.
Yes, sir.
Okay, same thing we can do. We can predict, no problem, by the different approaches. So far we have discussed only do nothing, just copy that code and we can do over here. Nothing. So we have already discussed all those. We have already discussed so many things. Right now we are doing. So right now, according to your need, what I'm doing, I am just checking the accuracy of my model. So that is the point. That is the not the model evaluation. So here I'm just checking the accuracy of my model. So that is the point we need to keep in mind. Here we have the poly dot scores and test x test comma y test. So we are testing the we are using the accuracy. So based on the testing data, we are just getting its accuracy. So just let me execute this code and see we are getting the error. Okay, the polynomial feature does not support this feature. So uh, we need to calculate some poly score. So first we need to transform score poly regression. Okay, this is supported not by the this not supported by the this part. So quiz this not support. So there is another method we can use, but here we are not. So polynomial we are getting its accuracy. So how we can get, so we can get by the score. Same thing we are getting over here. We are getting each and everything over here. So there is no issue. Why it is working? Okay, this is only the linear regression. So yes. Okay, here we can use some other values we can predict. So instead of the this object will not work right now. So I will update that code over here, that one. But just let me clarify this point. If you are using a linear model and you are what we have, that is a descent tree. So on the basis of the data set, if you try to check the accuracy, then how you can check, that is my point. So if you want to check your accuracy, then you can just let me execute this right now. Maybe I hope it will work. So because the accuracy is so good. So no, it is also again not working. It means this is not a part of this function. So I will need to check this function later on. So I will check it. But let me clarify right now. If you are using linear regression and descent tree, then if you need to check the accuracy, so what the value we got from the linear regression, 29,714, and from the descent tree we are getting some values over here in appropriate manner without write out. So you can see over here that is 35,000. If I just need to calculate the accuracy of the linear the descent tree, so I just need to use this score method, and that is by default method. No need to, we are not need to import any other libraries. But if we need to import some other library for the matrix development, that is accuracy score, we can do. If we need to use the R square score, then we can do. We need to import some other kind of the matrix we can use for the computation purpose. So that is the things that is inside into the SQL library from the matrix class. But right now we are not using, and there is no need to think. So model evaluation is saying to us what is the performance of the model. So we need to check the model performance. So based on the score parameter we are checking, so we need to check its accuracy. So let me give this code, and you can able to see. Linear regression model is just providing the 85% accuracy. So it will give the value 0 to 1, but I'm just multiply by the 100, so we're getting the value 85%. We are getting the 85% accuracy of the linear model by the train data. We have used the train data by the 80% data. We are getting the accuracy of the descent tree for the regression model 94%. So from this point, you can justify, you can able to see what is the probability, what is the possibility we should choose for the prediction purpose. So of course, descent tree is better than the linear regression, and of course, it is better than the polynomial, other kind of things. That is my point. So if it is better than the other kind of regression approaches, so definitely it provides a good accuracy, and that is my point. Is it clear right now? I will check the code of the dead point why it is not working. So I will check maybe some classes missing because it does not support such a kind of feature. So I will check that one. I will update. So now for this point, do we have any doubt?
No, sir.
No, sir.
Is it clear how we are getting the accuracy? So according to you, now tell me which model is better, descent tree or linear regression?
Decision tree, sir.
Descent tree. And that is the point we need to keep in mind. Within the simple words, we can say descent tree is better. So descent tree is always better for the regression when we need to predict something. But when we're talking about the regression, normal regression, that is not a good. Descent tree is always better for the predict the data, but descent tree is not better for the classification. When we need to do classified, it can do, but it just missed some information. So computation is in bad manner. So due to some error, you can say classification for the classification, descent tree is not a better option. So that's why we will not much focus on the descent tree with the classification, but I will share the code for a betterment. So now, but here we have a question. So how my descent tree look like? Okay, so that is my point I have written over here. How my descent tree look like? So what do we have? We're fitting our model as per the XY value. Why XY value? Because in the training data we have the 16 values, 16 data, and testing data we have the 4 values. So you can fit your model with the entire data. So what is entire data? We have the X and Y. So we are fitting again the model, that is a descent tree regression object. We need to fit this model XY. So you can see that might be over here. And here we need to use some part that is known as the graph. So what is the value we have over here? That is we have the use, or we have to use a method that is known as the export graph base. This export graph base will pass some data into textual way to the ML dot library. Instead of doing any library, you can rename any library like txt and so on. So that is the name of the file which store the information of the flow of the descent tree, where the left node will go, where the right node is going on, and so on. So okay, so here we are choosing the feature on this salary, no problem. Okay, here we can choose any experience, like the number of experiences we can say. So here we need to pass any kind of feature, it's option. Okay, it's option, we are not passing, it's okay, doesn't mean. But instead, rather than we need to pass something over here, so we are passing the salary feature because we need to produce salary. And what is the method? Export base. We need to use the object name, that is regression dt, and output file name will be the ml dot. You can use like textual any file name what you want to use, you can use, where the textual information to be stored. And from this point we can say if you need to print something. Okay, so I'm just executing this code right now. Now after executing this code, the all the information to be stored into the my textual way, but it is not a good idea. But how I can say my information is to be used for the display purpose? So for display purpose in the graphical way, what I have used right now, I'm using the tree class from the SQL object, and by this approach, I'm using the tree class. In this tree class, we have the plot tree method, and by that, we need to pass the object of the our descent tree regressor, and from this point, you will able to see the descent tree is generated. So that let me execute this code, and after the few seconds, the tree will be generated based on the experiences value. So now, what is the experiences? Here we have the decently random state. Okay, okay, let me. It is already executed. So yes, yes. Where is the point? Yeah, a descent tree regression. So we use a descent tree state random state 0. So this parameter you are not passing by default. It will take a 0. So it will choose any random value from the our here the experience value 1 to 20. So from this point, the descent tree will decide on root node. Okay, and from that root node, it will take some value. Just like suppose it is taking 14 or 15. So it will take a 14 or 15. Suppose I'm taking right now. So it will take the salary who is greater than the experience greater than 14 or 15. So it will decide the left node or right node based on the salary. So that is the condition we have over here that you can see. Now 12.5. It is visible. The tree is visible. Tree is visible.
Yes, sir.
Yes, sir.
Okay. Now this tree contains total number of the node total number of node in a log. So I'm just little bit amendment something for you, then you can understand within the 5 minutes. Yes. I'm putting my model for the testing data because in the testing data we have the only four values, and see how the testing data based Regression tree will be generated. Right now I'm not using the entire data. I'm again ready. Okay, so now let us check this point. Now this tree is visible right now. Okay, just let me use 10 and 10 size, and let me use the font size 10. Now it is visible right now. I'm using the only testing data. So how many values we have? Only the 4. So I'm printing the my descent tree by using the testing data only. I'm not printing for the entire data 20. So it is not able to see perfectly. That's why I'm saying. Now, so you can see what are the values in the testing data we have. We have the testing data value. We have the 16, 9, 10, and 19. So the random value which is entered into on this range is chosen by the descent tree, that is 13. So from 13, the value which is greater than or less than. So less than 13, we have the 9.5. The value which is greater than 13, we are having the 17.5. And now MSE what? MSE is the mean square error that is to be represented by the descent tree regression, that is showing the performance of the. So measurement of the descent tree can be identified by the its number of the error of the node. But in the classification, instead of the MSE, what we have the entropy. So when we display the descent tree by the classification, then we will have the entropy or information gain value rather than the MSE. So why we are having MSE? Because MSE defines the its node error. Sample total will be the same 4. Of course, the 4 testing data we have the value. So expected salary of the person who have the salary close to 30, that is 84,250. Now 30. Okay, so 13, 80,000. So it will represent the value very close to the that part. It is selected by random. So value to be generated by automatically by the descent tree. So if we have the 9.5, so features based on the features, its value is selected. Now here we have the two samples, the value which is less than or greater than. So this is what is the condition. So here we are having only the one feature, that is the number of the year experiences. So instead of the number of the year experiences, you can pass multiple features over here, and from this point you can decide. You can decide the how many features. So multiple features you can pass as like by comma repeated. But here we have only the one feature. That is my point. So total number of the sample we have the only 4. So at the last you can observe, at the last you can easily observe there are only the four values will be there because we have used the 4 testing data only. And now at the last MSE will be 0 because leaf node does not contain any error. So MSE value will be 0. Sample 1 means there is only the one node, one value, that is the last node. And it will not be divided into the other vector. But the sample here we have the 2. So it defines the we have the 2 part. That is the point. So this is the value 47, 50, 1 lakh or 1,40,000. So here see all these values at the leaf node will come. You can see over here. That is for the 16, and we have the value which is having that is to be printed by see. I'm printing X text X by text. So you will be able to see. Okay, so 1,47,50 and 1,50,000. This will be our last value we are getting. And to each and every node, if we need to find the impurity of each and every node, so what is the formula? The object name of the regression tree, and tree underscore is the name of the variable, public variable in the tree class. And we are using the impurity variable. After getting this point, we will get the 1, 2, 3, 4, 5, 6, 7. Why 7? Because how many nodes we have? 1, 2, 3, 4, 5. Okay, let me reduce some size and you can able to see 6 and then 6. One side I'm taking only the 12, then you will be able to see perfectly. 1, 2, 3, 4, 5, 6, 7. So total number of 7 we have 7 node. So each and every node contains some impurity. So how we can get this is the simple equation. That is the point.